Hi guys, and welcome to a new tutorial of Blender and Geometry Notes. Today we are going to create a procedural mirror like IKEA style. It will be a little bit tricky, but I hope you will learn something from it. So let's get started. I'm working on Blender version 3.3.1. Go up in the plus button, General and Geometry Notes. For this tutorial we will create a circle curve, and next you will understand why. Press New to create a new Geometry Notes here, and the concept for this tutorial is this. We will create a spiral like this with some parameter. We will align this spiral on one axis to have the correct origin point of this shape. Then we will create a circle like this, or we will use a custom curve to instantiate the spirals using the methods described in my previous tutorial about positioning and scaling instances on curves. You can check out this tutorial here. So let's jump into the Geometry Nodes system. Okay, we can create the spirals. So press 7 to go to top of orthographic view, create a spiral. We can drop this link and we can export the resolution, the rotation, the start radius, the end radius, and set the height of 0. Shift Alt and click. This is the first spiral, and we will create two parts, one in one direction and one in the other direction. We will connect them together and we will tweak the position and the alignment of the entire shape along the x-axis. So we can go in the group, rename it in the spiral resolution, set the rotation to an integer number from 1, and we can set 1 to start. Why an integer? Because if we have 1, it will be easy connect the first spiral to the second spiral. Otherwise, it would be more tricky. So now for the first spiral, I need to transform, so to shift this spiral with a combine XYZ information, link the vector to the transform because we want this point in this point here. So this point is the end of the radius and this is the start radius, so we want to shift this by the end radius itself. Multiply this by -1, link this to the x, and this is the first spiral. You can set these spiral 1 rotations, spiral 1 start radius from 0, and spiral 1 and radius from 0. Now we want a second spiral to the other part of this y-axis, so we can select these nodes, Shift D, click, and now we want to transform another time this geometry along a -1 in x and y. We can join it together. This is the final result. So it goes to the other part and the other part on the y and on the x-axis, but we need other spiral rotations, start and radius, so we can add other attribute here, rename it in spiral 2 rotations as an integer from 1, spiral 2 start radius from 0, and spiral 2 and radius from 0. Ctrl H, set 1 to the rotation. Now select all these nodes, Ctrl J F2, spirals. Now this is the easy part. Now the tricky part. We want to calculate the maximum y point of each of these spirals, because the concept is find this point, calculate the angle between this line and the x-axis, and then take the smallest end radius of each spirals and rotate the entire shape to get this maximum point on this horizontal line. So we want an effect like this, and to make this calculation we will use the bounding box of these two spirals and get the maximum y information for both of them. So we can add a bounding box for these. We can separate the max vector in the XYZ information. So the maximum point will be this point here because it is the max point of the entire bounding box. And finally, I want the attribute statistic of this original shape, and in the tail I want the vector of what of the position attribute here, where the separated value of this position has the y information equal to the y information of the maximum point with 0 as the epsilon. Collapse this geometry on the join geometry here. I create this dot for a moment, drop this. I want to get this point intersecting the condition where the y value of each point of these spirals is equal to the maximum y value of the max point of the bounding box of this spiral. So if these two values are equal, I can select the position of the point that I want, and I can extrapolate the max position or the min position. It's the same. And now I can separate these, select this node, Ctrl H to have only the attribute used, collapse this node, can move this node here and link this here. And now we need the same approach for this spiral, so I can select all these nodes, Shift D and move this here. I can link this geometry here, link the source of these in the bounding box. I can collapse these nodes, move up a little bit. And now we have this point and this point here and here. We can separate these information to get the vector information of these 2 points. We can rotate not from this point but directly from this point the entire mesh. So we can use this as a pivot point. To do this we can use a switch node, and when this value of the y is less than this y value, we will choose this point as a pivot point to rotate the entire mesh. Otherwise, we will use this point to rotate the entire mesh and align the entire shape to the horizontal line. So if the first y is less than the second y, we will choose, or the opposite. So if it is greater than this point, we want to use this. Otherwise, we will use this value for the pivot point. Perfect. Now we can select these nodes, Ctrl J, F2, find max y border point. We can select these nodes, Ctrl J, F2, find pivot point. Now, as described before, we want to calculate the angle between these two lines. So we remember that if we want the z value of this system, z is equal to a sin alpha and x equal to a cosine the alpha. So if I take a from both of them, I can write that a is equal to z divided by sine alpha and is equal to x divided by cosine alpha. If I move this up and this down, I can write sin alpha divided by cosine alpha is equal to z divided by x, and because this is equal to tangent of alpha, I can get the alpha as the arc tangent of z divided by x, and this is our formula. So I can take this and subtract what the other vector here, separate this vector. So this subtract node gives me this a vector here. I separate these in the 3 axes and I divide the z component by the y component, calculate the arc tangent of this value, and now we need to make this entire mesh as a one mesh, not 2 curves but one single curve. So to do this I need to add a curve to mesh node here without a profile, then use a merge by distance here and add a mesh to curve another time to have only one curve. Transform this geometry to an instance to have a single object here and rotate this instance using this previous pivot point, so this pivot point, and combine XYZ node where we want to link the rotation here, and we want to use this rotation on the z-axis. So because we want to rotate in this plane, we link this to the z-axis and we link this to the geometry. We can decrease a little bit the radius And the rotations, so we can set 2, for example, 0.09, 1.33 to rotation, 0 and 1, for example. Here we have an issue because here there is a problem. We need to transform these by the end of the second spiral and not the first, so I need to link these to these, not here but here. Okay, perfect. We don't see anything because yes, is not here, the Z component. I was confused by my previous tutorial for the X and the Z component, but in this case we have a plane like Y and X, so this is the Y component, Y and Y. So we need to divide Y component by Z component, and now we will see these, but the orientation is opposite, so we need to multiply this value by -1, so the direction is not in this direction but in this direction, and link these to the Z. Yes, now they are aligned. I can delete the annotation here, and you can see this weird effect. If you look the position when we don't have rotation, so if I mute these for a moment, we have the maximum point here and the maximum point here, but if I take this mesh and rotate by this point to this rotation, the problem is that we have a new position on the Y axis, so these and these will be the new points, and if I unmute these, you have a correct rotation, but both of these values give us new Y point, and this gap between these two horizontal lines grows depending on the radius of this spiral in relationship with this and radius of this spiral. So if I increase this radius, you can see the gap grows. So we need a rotation compensation to this previous rotation, and we can calculate this compensation by the ratio between this end radius and this end radius. At the end, we can use a map range to compensate with eyes this little gap. So to do this, I can use a group input here. I can divide the end radius with the end radius of the second spiral. This is our ratio, Ctrl H, and we can use map range with this value from 1 to 10. We want 0 and 0.25. We can use this in a combine XYZ node here. Now we are speaking the radiance language, and we can add to this vector this new vector and use these to compensate the rotation of this. Now you can see it's almost correct. We could adjust this a little bit, so 0.3 is a better number. Okay, perfect. And we can select these nodes, collapse these, Ctrl J, F2, rotation, compensation for big and radius different. Perfect. Now we can select all these nodes, Ctrl J, F2, align spirals to x-axis. Now, next step, we need to align this entire shape on the y and the x-axis to have the correct origin point of the entire shape. So to do this, we can easily calculate the bounding box of this shape, and we can extrapolate the maximum point and the minimum point, so we can subtract from the max the min to get this distance. We can divide it by 2, then we can use this maximum value, extract the x-axis, and we can subtract from this distance this x value to get only this part that we want to use to shift the mesh on the x-axis in a positive direction. For the y-axis is more easy because we can easily get the maximum point of this bounding box, separate the x, y and z information and use it to shift in a negative direction the y value of this maximum vector. So we can take the max, subtract the minimum, we can separate this vector to x, y and z. I can take the x, divide by 2, and then I can subtract the separation value of this maximum value here. So this x is equal to this distance, so I can take this and subtract to this value to get only this piece of distance. At the same time, for the y, I can multiply it by -1 and use this in a combine x, y, z, link this to the y, and then we needed to add a transform node and link this to the transform. But nothing happens. Why? Because we have here an instance. Okay, so Blender can't calculate a bounding box of an instance. You need to add a realized instances before the bounding box. So now I can use these and link these to geometry output. This is the final result. Now I can delete the annotation layer and you can see if I increase or decrease the end radius of this spiral, I always have the origin point in the center of the entire mesh and the correct alignment on the z-axis. Now to have a better view of this spiral, we can easily transform these another time. I can set -1 here to have this correct result, and we can select all these nodes, Ctrl J, F2, realign spirals. Now we can think to the mirror shape, so we can use a simple circle curve. I can see it. I can add a group input node here. I can export the resolution, the radius, and I can add another attribute as the mirror ratio from 0.0001, and we can decide if we want to use this generated circle mesh or use a custom curve. So this is why I created an original base geometry as a circle curve in the initial point of this tutorial. So we can add a boolean attribute, call it mirror custom. I named this in this way because we have mirror, mirror, mirror as the prefix of all the related attributes. So now that we have a mirror ratio, we can transform this curve cycle and manipulate the scale depending on this mirror ratio. So we can select this and combine XYZ on the Y axis, for example, link this to the scale, mirror custom to 0, mirror ratio to 1, and 1 for the X and Y for the Z. Now if I move the ratio, we have this behavior. So maybe you have seen some mirrors with this shape. Now we can use this switch to choose what geometry we want to use in this layout. So if the mirror custom is on, I want the original mesh, otherwise we want this transform curve. And if I decrease the resolution of this curve, you can see this weird effect. Here we have a ratio like this, and because we want to have a uniform length of each of these edges, we need to resample another time after this switch using the same mirror resolution here. So we can call this mirror resolution, mirror max radius. We can use the same mirror resolution here. I suggest you to increase the initial definition of the curve, so set 64 here in the resolution preview, go to modifier, and if I increase the mirror resolution, I have a more uniform point distributed on this curve after the ratio amount. So if I don't use this resample curve, I have more stretched lines here instead of these lines. But if I unmute this node, you can see a more uniform length of all these edges, and this will give us a better result on the instantiating operation of the spirals. So I can create a dot here, collapse these, we can select all these nodes, Ctrl J, F2, mirror curve. Now we can increase the mirror resolution to 100, for example, fill the curve using triangles and set material to this mirror, so we can create a simple metal material, metallic, no roughness. Select this to the metal or mirror, and this is Ctrl J, F2, mirror. Now, before instancing the spirals, we want to add a profile curve to this mirror. We can use a quadrilateral shape as the IKEA style. We can export the thickness of this quadrilateral, so I can link this and rename it in profile thickness. From 0 is perfect. Link this to the height. Then I want fillet curve here, and we can export the profile bevel here. I can rename it in profile bevel. Select poly, and we can export the count of the beveling. We can call it profile resolution. Move up, Ctrl H. But now if I want to have a good result, you need to tweak a little bit this environment. We need to check this limit radius. Now you can see that if I increase or decrease the thickness of this quadrilateral, the beveling changes their result. So I want to maintain linear proportional values between the profile thickness and the profile bevel, and I don't want to use a static number. I want to use only a number between 0 and 1 for the bevel. So to do this, I want to use a single float value without a unit measure, so I decided to drop this, delete profile bevel, add a new float value, profile bevel. So this hasn't a unit measure, from 0 to 1. So 0 no bevel, 1 the maximum bevel, and we can say this: if I have 0, I don't want any bevel. So if I have 1 here, I want the maximum bevel, so the maximum radius, but the maximum radius is the thickness divided by 2. So this is the maximum radius. So to do this, I can get the profile thickness divided by 2 and add a map range where I can link the profile bevel in the value, and from 0 to 1, from 0 I want 0, from max 1 I want this value to be the thickness divided by 2, so the maximum value I can have in this curve. Now I can link this result in the radius, and if I decrease to 0 or 1, I have this correct mapping range, and I can increase the resolution I want. But one thing, I don't want to have the bevel in all these 4 points. I want to have a sort of C shape with only 2 bevel points and a sharp edges here and here. So to do this, I need to delete geometry. Before the fillet curve, I need to delete the edges, but not all, only the edges that has the index equal to 1, for example. Use this for the selection, but keep in mind you don't see the deleting operation because we have here a curve, so we need a curve to mesh here before the delete geometry to get a correct deleting operation, and then a mesh to curve to let us fillet the curve here in this node. And now if I press Shift Alt and click, you can see the correct result. So sharp, bevel, line, bevel and sharp here. We need to close this curve, so it's simple. I can set cyclic to this curve and set this, close the curve. Now I can add curve to mesh node, link the curve of the mirror and not this, because this is the true mirror, so the true surface of the mirror. I need the curve, the original curve, and use this here, checking the fill caps, and we can use a join geometry to see all these results. So so the mirror, and custom mesh, and link this to the geometry. So now the radius is very big. I can decrease these, shift C to see the result. I can decrease a little bit. Now you see this weird effect about the auto smooth here. So I can select this button, the shade auto smooth, but we need to fix it, and you can have access to my previous tutorial for fixing auto smooth, and you can check it out here, or you can wait the next part of this video so we can fix it easily. We add a group input here. We can delete the geometry where the index of our points is not equal to 0 to delete almost all points. Link these to the joint geometry here, and we need to set smooth here in our geometry. We can set material to our profile curve, so we can add not a mirror but the iron, for example. We can select these. Okay, now you can see anything because we have an original object as a curve and not mesh. So to have the correct auto smooth result, we need to use a mesh. So we can do it. Right button, mesh, circle, and this is simple circle when I can set 100, for example, for the resolution. And for our next purpose, we can use these, enter in the tab, select this point, press O to enable the fall-off proportional editing, G to move, and we can move these here, for example. Now you can add a geometry nodes, select our geometry nodes. We need to paste the same information of the geometry nodes of this curve, so I hide this for a moment, select these, shade auto smooth, and you can see if you use a mesh, a original mesh, the auto smooth feature is fixed, but using the curves, Blender can't help us. So if you know how to make these in the geometry nodes starting from a busier circle, please leave a comment. Now we can go to the next part. We can select all these nodes, Ctrl G, F2, mirror profile, and we can select these nodes, Ctrl J, F2, fix auto smooth. Now that we have the mirror, we can select 7 to see the result from the top orthographic view. And now for this tutorial, I decided to let you decide what method you want to use to instantiate the spirals on your curves. So in detail, I decided to use two methods. One is by angle, so use the angle of these curves to know where I want instances. I want the instances in big angles here, or I won't have instances on this part of these curves. So this is a good choice if you have custom dynamic curves that has big angles or small angles and you want to instantiate the spirals on these curves automatically. The other method is the custom instantiating of the spirals. So you can decide where you want to have it and you can decide the scale, the minimum and the maximum scale you want. In the first method, you will have the minimum and the maximum scale in an automatic way depending on the angles of the curve. So to do this, I need a new attribute here to choose what method I want. So this is a Boolean value, spiral angles custom, and now we can instantiate our spirals on our curve. So I need the curve here and I want the spirals only on some points on this curve, not everywhere. So I need to resample this curve, but before I need to store or capture the normal of each point in this height resolution of the curve, because we will need it after. So I can indicate here the normal. I want to save the vector of the normal in this shape and then resample it by a count that we can export in the group input. So we can call it spiral count from 1. Now I can select this, Ctrl H, and link this here to have more space, and we can instance on point where on my curves what the spiral we have here. So we can select this and link here and add these to the join geometry. We have scaled them a little bit, Shift Z to see the curves. Now we need two things. One is the rotation, so we can use the easy normal attribute and use the align Euler to vector, and because we have the spiral in this axis, so to the y-axis, we want to shift the y-axis to the normal of this curve and use this to the rotation. This is the final result, but there is a problem. We need to translate the position of this spiral along the normal by a factor. This factor is caused by two parameters. One is the thickness of the profile of the mirror, because the curves goes along the center of this profile, and the other parameter is the profile that we will use for the spirals. So we need to add a spiral profile from 0, and we need to add here after the instance on point a translate instances with no local space in this case, and we want to duplicate the group input. We can press Ctrl H because we need here only the spiral count, and here we want to use the spiral profile that is a float number from 0. We want to add the profile thickness with the spiral profile, so in this case not the thickness itself but the thickness divide by 2, because the thickness is the total distance from here to here, so we want only the middle part here. So these added to the spiral profile, and use the original normal scaled by this amount, and use this to the translation of our translate instance. So I can link these and these to the output geometry, and you can see the little different of these shapes. So I cut these, I set a spiral, a little value of the spiral. You can see the little issue described before about the rotation and the alignment between the shapes. So I suggest you to increase the resolution of the spiral, 100 for example. Next we will add a profile curve on the spirals. Ctrl H these, move it a little bit, all these nodes a little bit up, select all these nodes, Ctrl J, F2, spirals on mirror. Now that we have the translated instances, we need to realize these instances to get the control point and the splines, because here we have only instances. And now we can add a curve to mesh node using a circle curve as a profile, and using a group input node here, and link the spiral radius here. So the spiral radius, Ctrl H, link the curve here in the profile, fill caps, decrease the spiral radius to 0.0035 meters for example. Now we can set the same material as the profile of the mirror, so set material here, select the iron. We can select all these nodes, Ctrl J, F2, spiral profile. If you want, you can add a second custom value here that we can export to add an offset, so we can call it spiral normal offset. Ctrl H, and you can decide if you want in the final result a little offsetting in or out. For now I set this to 0. Now we have a simple base mirror. Now we need some parameters to define the spiral scaling and the positioning on this curve. So we need a spiral min scale from 0, a spiral max scale from 0, a spiral offset from minus 0.5 and 0.5, according to my previous tutorial about the positioning of instances on a curve. If you didn't see, you can check it out in the top part of this video. And we will use the offset to offset the position along this curve of all these instances, and we will add other parameters next. So first of all, we can discuss the custom instantiating. So I can set this to 1 because I want the custom. Now, before use the scale and the selection filter of these instances, I need to create here the part about the scaling and the positioning of these instances. So to do this, I need to resample the factor of these curve before the instancing. I create here a dot, I create here a capture attribute because I want to save the float number of the spline parameter, because I want to save the factor before the changes on this curve. So now from my previous tutorial, I want to offset the position of my instances. So to do this, I need to use the group input here. I will use only the spiral offset. I want to add what? My attribute here, my original vector. Then I will use a fraction to have always values from 0 to 1, and then I use these to sample the factor of sample curve to redefine this geometry factor, and I will use a set position to move this geometry formation to a new points position that this sample curve gives me. Now, because we need to know what type of method we want to use to the spiral instantiating, angles or custom, we need to use the group input another time, and here in this place I need to use this spiral angle custom. So switch, if it is true, I want this in my capture here, and I want this final result in the true value. So this is the choice. I want to go up here. If we want a custom result, we want the output of this entire part to define the position and the scaling of these instances, rather than using the angles of the curve. So I can use this, Ctrl H, we can do some collapsing operation, and we can add some formation here. Ctrl J F2 offset, Ctrl J F2 override factor, and now if I increase the offset, you can see a correct offsetting of these spirals along the curve. Now, next step, we can use a spiral bias from 0 to 1, and we can use it Alt P G to move here. So the curve has a factor. I want to distribute this factor before the offsetting along this curve, but not from 0 to 1, but only from a range that can be a little small. So not the entire round, but for example from these to these, so from the 25% and 75%. So to do this, I need to use this bias with a map range. I need a value that is 0.5, so this point, okay, so I can shrink, I can say shrink this distribution to this point, starting from 0.5 and adding or subtracting a value, not this bias. The bias is the dispersion that we want, so the wide of my range from this 0.5 value, I can use this subtract as the minimum output, and this adding with the maximum output range for my map range node here, and I want to use the original factor saved here, so I can link these, and because the factor has a value from 0 to 1, I want to map this range from 0 to 1 to 0.5 plus or minus a little value to get this range, and use these in the offset here. Now we can see this effect. If I set the spiral bias to 0.5, you can see you have all the ranges from 0 to 100%, because if the bias is 0.5, we have 0.5 minus 0.5 is 0, the same value as the from min of the factor. 0.5 plus 0.5 is 1 to this max, that is equal to the from max value 1 here, so the same original 1 maximum value of the factor, so the result doesn't change. But if I decrease the bias, you see this weird effect, because we have a cyclic curve, so we don't need a cyclic curves here, and to do this we need a set cyclic value here. We can link the geometry here and the geometry here with this check off, and to better manipulate other cases we can export this cyclic to our group input and press Ctrl H, and we can call it spiral cyclic. Now if I set 0 to the offset, you can see the behavior of this bias, okay? You can see this shrinking effect, and now if I want to offset, I can offset this along the curve from minus 0.5, so this is why I decided to define this parameter from minus 0.5 and maximum 0.5, so the entire round. 0 is the middle value. Now we can select these nodes, Ctrl J, F2, bias effect. Now we need to save the scale of these points using the minimum and the maximum scale. So to do this we need to store a value that is the scaling, so we can call scaling for each point, link these to these and these to these. We want to save the scaling here. Well, we will use the factor with a ping pong effect, and we remember that if we use the ping pong with a value scale here, we need to divide by the same value to normalize the output always from 0 to 1. I suggest you again to see my previous tutorial about positioning scaling on a curve on my channel. And now for this ping pong effect we need a new value in the group input, so I need a new parameter that we can call spiral looping from 0, and we can use these here and here. We can collapse these two nodes, and we know that we want to scale this output in a map range where we have 0 value of the factor, the result of the factor. We want the minimum scale, and for the max scale I want the max scale, and this is our scaling. Now to see the result I can go here in the instance on point and easily get the attribute named scaling and link these to the scale. Now I can increase the max scale and the min scale as I want. I can decrease a little bit the bias, so perfect, the bias is 0.5. Spiral looping is 1 for initial values. I can increase the spiral counts and decrease the min scale to see better the result. So this is the factor you are seeing, and the scale follows this factor. Now you can see that I can use this looping to create the ping pong effect. So I want 0.5, and this is the effect, so from 0 to 1 and then again to 0. If I set the 0.25, I have this effect 0, 1, 0, 1, 0 and so on. Now because in the next part we will filter the visible of these instances depending on the scale, you can imagine that I want to shrink the min scale not from this point to the maximum point, but having a minimum range before it goes up to the maximum scale. You will better understand next with the filter, but now because we are here we need to add another attribute here, a float number that we can call spiral shrink value from 0 to to 1 because 0 I have no shrinking and 1 is the maximum shrinking, so the minimum scale needs to be from here to the maximum scale, so the total shape. I can use these in a map range here. I can select these nodes, G to move a little bit. Here I can take these, okay, select this, Ctrl H, this value here, this output is here. Now I don't want these from min-max 0, 1 to 0 and 1. I want the 0 value, so next the to min value, so the min scale, not from the 0 value of the output of this ping pong, but a value that can be reader. So if I link this spiral shrink here, I can have this effect. I increase a little bit the spiral counts to see better the result, and you see the spiral min scale starts from 0, okay, this would be 0, and if I increase this shrink, you can see the map range has effect because the 0 starts to move from this point to this point. So if I set this 0.5, I have 0 from this point to the middle point of this part of the curve, so the first ping pong, because here I have 1 to the output of the ping pong, so the maximum scale set here, and I can use these to better filter the visible attribute of these instances of the spirals. So now that we have these nodes here, we can move these nodes, we can move the looping up and the shrink value up, perfect, and we can save this information here in the scale name attribute. I can select all these nodes, Ctrl J to custom scaling. Now we have the scaling attribute stored in our geometry, but we haven't it in the case of the angle method. So if I switch to the angle, I have no scale here. Now to also have this scaling value in the spiral angles method, we need to use this resample curve. So we have only these points, and we can use the shift and Ctrl to see the result. I can decrease this spiral resolution to see the points better. So imagine that you want to instantiate the spiral here where the angle is smaller than here, and we want to have the maximum scale here where the angle is smaller, or the opposite if I want. I would like to have big spiral here because we have a bigger angle, and then little here where there is small angles. So to do this, we need to calculate this angle. So to calculate the angle of two vectors, it's easy. If we have a vector like this and a vector like this is smaller than this, we can normalize both of them. So imagine that this is the normalized vector, and then you know that the dot product of these two vectors, if we have A and B normalized, is equal to A multiplied by B multiplied by cosine of alpha. And because we normalized these, the module of these is 1 and 1. The dot product of this result gives us cos alpha. So we can say that the alpha is equal to R cosine of the dot product result. In our case, we need to get the information for each point of this vector and this vector. So for this point, for example, we need to get the information of the index plus 1 and information of the index minus 1. So the position here is the position of I, here is the position of I plus 1, and here is the vector of the I minus 1. So we need to calculate this vector. To calculate this vector, if this is A, B, and C, B minus A is the first vector, and A minus C. We will normalize these. We will calculate the dot product, and then we calculate the arccosine to get the correct angles. And you know, if you have two lines, two vector, the maximum angles you can have is 180 degrees or pi in radians, and the minimum is 0. So in our case we can get from this a transfer attribute 3 times. So we need the vector of the indexed point, and we want the index plus 1 here. We want the position of this attribute. We need to duplicate these twice. Delete these. We want only the index in these, and we want to subtract 1 here. We want always the position. We can set the index only 1 time here in this selection, and here we can set these. We can choose the same source for these 3 nodes. We can use the same position node. Perfect. Now we can subtract to these nodes and collapse, duplicate, link these 2 nodes. We can normalize these, duplicate and normalize these, make a dot product between them, and calculate the arccosine of this number, and this is the angle. Now that I have the angle, I want a map range, and if the angle is 0, so very small, maybe I want the maximum scale or the opposite. So I can set these from pi to 0. From the group input, I want the minimum scale here and the maximum scale here. Ctrl H, and now I can store these in the geometry, in this geometry, and we keep in mind that we have here the result of this first selection of the spiral angles and custom, and we need to duplicate these another time to say to our layouts that if I have the spiral angles custom, I want the original curves, otherwise I want the changed geometry that has the scaling value. Now this output is the output that I need to use in this instance on point. Can use this and drag here. Ctrl H, can move these nodes a little bit. Now I can test it, so we can shift and click these. I have these 0, so I want a spiral angles method, and only these 2 attributes work in this method. So I can increase or decrease this scale and increase or decrease the maximum scale. Now you can see that we have 2 problems. One is that the spiral min scale value, so 0, there isn't in the minimum of these 2 angles, and we want that. And the other problem is that we have no information about the angles or the position of the index. Subtract 1 if the index is 0, so the minimum index we have in the curve, or the maximum index plus 1 in the curve. So to fix these 2 problems, we need to do this operation. We have to think in a similar way like this, so adding a map range here when we need the minimum and the maximum value of the angles, and use them in the map range with the minimum and the maximum scale, and one other map range to use the same attribute spiral shrink. So to do this, we need an attribute statistic. We need to link the same geometry here. We want the float value of the arccosine, and we need the minimum and the maximum. Now we want to use this minimum and the maximum in a map range, and we can use this first map range, so we can link the minimum and the maximum of the angles. We can cut these links, move this a little bit, and use an output of 0 and 1, and use another map range when we want from 0 to 1 the minimum scale and the maximum scale. Why this step? Because from the group input we can use the spiral shrink attribute to distribute the minimum value of the spirals along the entire factor of this curve. So Ctrl H, now we have the correct scaling, Ctrl H in this node here, and you can see there is another little problem. I used one vector in this direction and the other vector calculated here in this way, so I need to reverse this direction to have a correct angle between these two vectors. Otherwise, if I use this direction and if you shift this vector here, I would get this angle, but I don't want this angle, I want this angle. So to do this, I have to reverse the direction of this vector, switching these two vectors here. So I want this vector from index +1 minus the index itself and the index -1 minus the index itself. Now we need to adjust this calculation because we could have a curve cyclic or not cyclic if I use a custom curve. So to do this, I need to have an equal to a value, and we can extract the number of points of this curve by a spline length node here, and we can set if the index subtract 1 is less than 0, so -1. I don't want this value, but I want the maximum index, so I have to set integer here, link this switch, and if this is true, I want the point count subtracting 1, because the index is 0 indexed, we can link these. Otherwise, I want the same value of the calculation of the index, so index subtract 1. And now I can link this switch to the index of this transfer attribute node. To the other part, I need the same two nodes. I can duplicate them, I can set these, and when the index adding 1 is greater, or we can set equal to point cloud using 0 epsilon, here we want to use 0 index, so the first index of the curve. Otherwise, we want the result of this adding, and we can link this switch to the index. Now, if you use the shift control click on this geometry and this arcosine to see in the spreadsheet the values of this arcosine result, you can see the correct values. So at the 0 point, so here, and the index 8, so here, we have the minimum value of the entire sequence of numbers. We can drop this node, Shift Z, I remove the annotation layer, and you can see now I have 0 for the min scale, and I can shrink like this value from the initial point to the maximum point of this curve. So if I set 0, I have a correct increasing of the scale, but I can increase the shrinking and have the minimum scale for a large range on the curve. Now we need a last piece of layout, that is the selection, so the filtering of these points on which we want to instantiate the spirals. So to do this, I can use another stored attribute that we can create for a custom method here and for the angle method. So before this, I can select all these nodes, Ctrl J F2, scale by angles, and now for the filtering we have 3 little steps. One is save or store in this geometry a value like filter is a float, and in this case we want to save the value of this map range, so before the use of the shrinking, because we want to filter the points using the proportional values of the original scale from 0 to 1, or in this case for the angles from the minimum and the maximum angles we have, and leave the shrink after this point, and you will know why in a moment. So now I can link these to this filter, and second little step, the same operation here. When we want to save for the custom instantiating, we want to save this value in the filter before the use of the shrinking parameter, sorry, not this result but this result, so the value before the shrinking. And you can see the difference in the custom scaling. We need to use the value from 0 to 1 from the output of this ping pong, and in this case the same values from 0 to 1 before using the spiral shrink attribute. And now that I have a filter here and the same filter information here, we can go in this part and use the attribute we saved. We can set filter, and we can add another two attributes: spiral filter, that is a float value from 0 to 1, and we can use another filter that we can call spiral filter inverted as boolean. So in this way we can instantly invert the selection of the points on the curve. Now I can import a group input node here, and because we have values stored from 0 to 1 in this filter attribute, we can use directly the spiral filter parameter, and we can say if the filter is less or equal, and the other part if it is greater than or equal the spiral filter. So we can link these here and here. We can use a switch as a type of boolean, and we can filter only the values up or down of this filter thanks to this spiral filter inverted. So if it is true, we want, for example, the values less than or equal, otherwise these other values. Ctrl H to this node, we can select all these nodes, Ctrl J F2 filter points, and now we can easily link this switch in the selection of the instance on point node. We can play with the position of this layout a little bit, and now we have all the nodes we need to play with this environment. So we can set the shrink to 0, press Ctrl H twice to hide the attribute not used, and we can press Ctrl H for each of these group node in this layout, here, 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 and in the initial part of this tutorial. And this is the entire workflow. Now we can see the result, so I can go in the layout, look the mirror, we can see the preview of the materials. We can select the Eevee for a moment, disable the bloom effect, go to material and see if this is correct. We can select the iron, select a dark gray, increase the roughness a little bit, and this is our result. So to better see the final result, we can turn on the solid material, press 7, and we can play with our parameters. Thank you guys for watching this tutorial. I hope you like it. If you want to leave a comment or check a like, I will appreciate it. You can download this project from my Gumroad page or create it from scratch. If you like what I'm doing, please subscribe to my channel and check the bell icon to get a notification about new posted videos, and see you to the next tutorial of Blender and Geometry Notes. Bye!